Hi, and thank you to doctors Nikki Gorell, Mark Plew, and Brett Chapman for organizing this conference and for inviting me to speak to you all today. It's a real honor and privilege to be asked to speak to the Idaho Archaeological Society, especially as I am a new faculty member at Boise State University, and the new director of the Center for Applied Archaeological Science. It's really too bad that I can't be there to meet you all in person, to get to know you, because that's what these things are all about. So I know we're in strange times right now, and especially what I want to talk to you about is about an integrative and data-driven framework. So can't do much integration via Zoom and teleconferencing. Nevertheless, I look forward to meeting you all soon. So what I want to talk about today focuses on the changes that we're currently going through in archaeology as a field across all components of our field. And I want to focus specifically on how what the role of universities should be in this new atmosphere. So as an outline, I'll first be talking about and introducing the problem of the recent data deluge in archaeology. I'll then move on to talk about the big data prospects and challenges in American archaeology, because we deal with some specific challenges, not only at the federal level, but also at the state level. And we need to talk about those specific challenges and prospects. And lastly, I'll be closing by trying to approach the question of what can an integrative and data-driven framework do for Idaho archaeology. So first off, the recent data deluge in archaeology. Andrew Bevan, this name comes from the paper published by Andrew Bevan in Antiquity in 2015 called The Data Deluge. And in this paper, Bevan made some statements that are quite relevant to what I want to talk to you all about today, and really encapsulate the way the playing field has changed in a way when it comes to data in archaeology in the 21st century. Bevan says that archaeology has wandered into exciting but daunting territory. It faces floods of new evidence about the human past that are largely digital, frequently spatial, increasingly open, and often remotely sensed. The resulting terrain is littered both with data that are wholly new and data that were long known about but previously considered junk. This diluvian information landscape, I would argue that its consequences go well beyond the raw challenges of digital data archiving or manipulation, and should reconfigure our analytic agendas. They can legitimately be read for both a utopian and a dystopian disciplinary future. And they also re-expose some enduring tensions between archaeological empiricism, comparison, and theory building. So Bevan approaches this from looking at all of the various databases that have been developed over the past decades. The disparate nature of these data sets. This is the deluge. You know, in the top left corner here, you have databases for specific forms of material culture, such as point-based databases at a national scale, or coin databases specific to Roman coins, for instance, in the UK context that Bevan knows best and is speaking about. There are now growing databases of 3D scanned artifacts. On the second row, there's a growing compendium of archaeological, of cultural resource management site reports that are being posted online and being made more widely accessible for researchers. Oftentimes, a lot of the data we have is in the form of geophysical surveys and LiDAR-based data. That is where a lot of our big data is starting to accumulate at present. And then on this third row at the left, you have these somewhat confusing, potentially squiggly lines. And one of the largest forms of big data development in archaeology at present are the formation of large radiocarbon databases. And it's those databases that I would like to talk to you all about today as a general framing and framework for considering Idaho archaeology. And Bevan closes with a few final thoughts that I think we should use to frame what I would like to talk to you all about today. And that is that the metaphor of a single deluge of archaeological data implies too clear-cut a before and after moment, when in fact we will have to get used to chronic annual flooding. Regardless, the operating conditions for archaeological research are being transformed. The need for more specific computational and numerical skills will also probably grow further in importance alongside the growing complexity of our evidence and the scope of our explanatory ambitions. There's a pressing need to demonstrate that our information glut does indeed lead to better, rather than just more, archaeology. The risk is that we will now enter a rather undirected phase of gathering even greater amounts of evidence while assuming that it otherwise largely speaks for itself. A more adversarial analytical approach is called for, in which we harness increased flows of archaeological information to set up explicit forms of comparison and contrast. While we should avoid undermining the kinds of detailed, hard-won specialist knowledge that remain key to proper understanding of the archaeological record, this comparative effort will also need to cross some persistent subdisciplinary barricades and work ultra-longitudinally across different chronological periods. Periods that are usually treated separately in the same study region, trans-geographically across traditional regional or modern political borders, and counter-artifactually across constellations rather than single classes of material culture. What Bevan was talking about was really specific to the situation in the UK, that he knows best, lives and works in. And what I want to introduce now are the specific problems and challenges that are most germane to the context of American archaeology. There are a host of various issues that make the prospects and challenges for big data very unique in the American context. And I would like to talk a little bit more about these, because I think that the framing of these problems and challenges at a nationwide scale really helps to inform the challenges that we have at the statewide scale, and also gives us glimmers of hope for the future. So my research mostly focuses on how we can use archaeological data to understand deep time human population dynamics. And so being focused on this question and being focused on how humans over thousands of years adapted to climate and environmental change to develop sustainable communities. That question is not just a question that I'm interested in, but population has actually been one of the most important causal agents that's been assessed and attributed in all of human evolution. So for decades, researchers have focused on using different forms of archaeological proxy data to estimate population. These things have been based wide range of features and forms of data, such as floor area, site size, midden volume, food abundance, and pottery shear densities. There's just one problem with all of these. And that's that there is a lack of adequate measures of population that can be easily and realistically compared across cases. When we look at these estimates, things such as pottery sherd densities, we know that we're pretty limited geographically in how we can use those proxy data to infer population, let alone middens, for example. One answer to this problem is radiocarbon dates. And in the 1980s, in a series of papers, Mike and Cynthia Berry, they proposed that aggregations of radiocarbon date frequencies could serve as proxy data for the relative probability of occupation through time. This was the foundation of what in 1987, John Rick published, calling dates as data approach. And in this, the Berries, on the x-axis to the right, you have 1,000 years ago, 1,000 BP to 1,000 BP. The basic assumption of this approach is that for a given slice of time, let's say 11,000 years ago, if a given bin of time, we count all of the amounts of radiocarbon dates we have for that given amount of time. And for instance, if we compare that to 10,000 years ago on this graph, and we find higher frequencies of radiocarbon dates in one span of time compared to another span of time, we infer that there were most likely more people to generate that carbon record at that time. So date frequencies, aggregated date frequencies, give us an indication of population growth and decline. But I stress, these are relative measures. We deal with a fragmentary archaeological record. We deal with bias all of the time. It's not really enough to acknowledge bias in these radiocarbon proxies, but it's probably more to identify ways around these biases, ways of contending with these biases, ways of taking these biases on and handling them properly, honestly, and conservatively. So this power of this method really is derived in the continuity and the continuous nature of this. We're able to look continuously through time rather than look at blocks of time, either, as you see Clovis Point block here, you see late San Jose, San Pedro periods of time, and then you see the origins of certain forms of technology, all of which are discontinuous through time. The benefit of the radiocarbon data is that radiocarbon dates are ubiquitous in archaeology over the last 50,000 years if we're trying to understand the age of occupation of one of our sites. And how robust are these records? We know that they have bias. Well, if we look at a record of over 47,000 time diagnostic, surface collected projectile points throughout the Great Basin, we will find that those frequencies of a completely independent measure that's not radiocarbon dates actually has an extremely strong correlation with the frequencies of radiocarbon dates. This value right here, this correlation of 0.988 should help us have a lot of confidence that these records are actually telling us something about demography on a landscape. So in 2014, Bob Kelly at the University of Wyoming was funded by the National Science Foundation to collect every available archaeological radiocarbon date from the lower 48 states. I was a postdoc working with Bob on this project. The top graph shows the amount of dates we have from every state. And this is a very important point about utilizing all of the money that we have used in the past for cultural resource management. For around $1 million that the National Science Foundation gave us, what you're looking at is that you're looking at over 100,000 radiocarbon dates that represent $40 million worth of publicly funded work, publicly funded radiocarbon ages. Most of those ages would have potentially never seen the light of day. They were in the specialist literature in regions, mostly cultural resource management reports. Therefore, for researchers that are working in other regions that have interregional or continental scale questions, those data might oftentimes not be accessible. So we have collected all of these dates, and we have made them openly accessible to the public as part of the Canadian Archaeological Radiocarbon Database. As you can see in the plot below, we can assess the variable densities of these things, all of these counties. Something I'll get into here in a second is that you see the spatial resolution of the densities of these. And this is because by law, we are still unable to release the exact spatial locations of these sites. So we're focused on assessing things within the county centroids. These are the only data that we're actually releasing on card, because we've got many things to discuss with agencies about how we should actually fuzz or blur these spatial data. So this plot, it reflects the number, it compares the total number of archaeological dates to the number of archaeological sites. So the number of archaeological dates that we have is on the y-axis, and the x-axis is the number of archaeological sites. Really focus your attention on the bottom part of the plot, or the bottom plot. If you were to draw a straight line through this, you would be able to assess that what's above that line is potentially oversampled regions, and below that that line would be potentially undersampled regions. Idaho is one of those areas. Idaho is one of these areas that falls underneath this line. And we think that compared with, states such as Arkansas, North Carolina, there might be a lot more sampling that needs to occur within the state. It could be radiocarbon-wise, could be an underrepresented state. I don't see that as a problem. As a new staff member working in the archaeology of the Snake River Plain in Idaho, this problem excites me. This is a problem that we as a community can potentially fix. So if we look across the United States, we're able to do something that we haven't really been able to do before with a really large, robust data set. And that is that we can start to look at frequencies of sites through time. So the left plot is showing you how many numbers of sites we have. And the right plot shows a summed probability distribution, so aggregations of calibrated radiocarbon dates. What's immediately apparent is that if we don't look at that, basically both of the records look similar to each other. Our site frequencies are really capturing a lot of these similar trends in radiocarbon data. So again, we are seeing these really, really large scale trends that continuously through space and time, we're able to reconstruct human demography on a scale that has not really been done before. But with benefits of this at the state scale come a series of challenges. And one of the most important challenges that we currently face right now is that for us to build national open access databases to enhance paleodemography and human environment interaction research in archaeology is that we need good spatial data. This study focuses on what happens if you use poor spatial data versus what happens if you use good, robust spatial data. The main inspiration for that problem is that we have been collecting these radiocarbon dates within state boundaries because that's how things are organized. And yet, if we're trying to understand demography, that demography is oftentimes cutting across these modern state boundaries. So we need to find ways of sharing our data and analyzing our data across these different areas. So typically, when we look at population growth on the y-axis, we have 12,000 years ago, or on the x-axis is 12,000 years to present, going from left to right. The top plot is from Utah, all of the sites in Utah, and the bottom plot is all of the sites in Wyoming. But we know these are bordering states. Oftentimes, folks are moving around. And so therefore, having these modern state-based designations in comparing demography can be a little bit like comparing apples and oranges. So what we thought about was, well, let's try to embed past populations into their ecosystems. Let's think less about modern state boundaries, and let's think about the sustainability of populations within their respective ecosystems. So what we can do, and what we did in this method, is we developed a method for downscaling and debiasing climate models from 10,000 years ago to 500 years ago. So 10,000 is up here in the top left, 500 is in the bottom right. As we know, climate's changing through time, right? So climate is not stationary. It's always dynamic and always changing. And of course, human populations would respond to that dynamism with their own forms of movement and mobility and migration. So we have to be able to embed human demography within these climate zones and really understand the climate and environmental context of human societies, not within these modern state boundaries. And when we compare the relationship of good spatial data to bad spatial data, when we look at how those data are embedded within these models, where they are at certain periods of time, we see a lot of mismatch between the county centroid level of resolution and the actual exact lat-long data from the state. And why does all of this matter? One thing that I have not mentioned is that we are moving towards open science approaches in archaeology, where all of our work needs to be verifiable and replicable by other researchers. So therefore, if we do this kind of analysis and we use exact, precise spatial data, we are responsible to publish those data, to make those data replicable, right, and verifiable by other researchers. Well, we can share those data, but if we do that openly, we are potentially opening ourselves up to the looting of sites, right? There are some serious ethical problems that arise with this question of what folks need in terms of the spatial resolution. Because what we see is that if researchers were using these data, and they were using the data that we've released a card under only the county centroid, there would be up to, in some zones, there's up to 86% mismatch between the exact locational data and the county centroid data. Okay, and so, and 10,000 years ago in Wyoming, there's 100% mismatch. Okay, so having this poor quality spatial data is actually minimizing. We've done all the hard work to collect these dates, but without this good spatial data, or relatively good spatial data, we're actually, we're not able to really use these data to their fullest capabilities. So we close this paper with, so what to do? How do we protect sites and yet make spatial data available to researchers with minimal effort? We note that the SAA has recently created a task force of sharing public outcomes of CRM that's chaired by Josh Wells at Indiana University South Bend, whose mandate includes drafting guidelines for the sharing of site location for research purposes. But awaiting the conclusions of that group, there are three major things that we concluded. First, this issue requires a conversation with relevant federal agencies, beginning with the lead agency on archaeological matters, the National Park Service. All parties, including federal and state entities, must recognize that we no longer operate in the research environment that existed when protective legislation was enacted in the 1960s and 70s. A regional study in the 1970s was probably contained within a state, but one today might encompass the continent. The idea of big data didn't exist in the 1960s and 70s, nor did the technology to store and analyze large data sets that cross-cut state boundaries. This has now changed. By controlling access to data, state authorities, as well as the federal authorities that provide legislative guidance, must recognize their ethical responsibility to assist in this new research paradigm. This includes the recognition that tribal sovereignty and consultation are central to developing new guidelines for data sharing in the 21st century. But the responsibility doesn't solely lie on those parts. This is a collective effort. The second advice is that state authorities should require that database gatekeepers, such as CARD, explicitly accept responsibility for the misuse of information contained in their databases. This might take the form of language in MOUs that absolve state authorities from responsibility should data be given to databases and be misused. Additionally, and accordingly, gatekeepers should create rigorous vetting procedures and publish those vetting procedures. These could include notification of the relevant state authorities when a state's data are downloaded from those systems. So we can create means to enhance this effort to protect the sites. The databases should also be accountable. The third is that locational data in databases could be made intentionally imprecise at a scale that protects site location and yet allows researchers to proceed with most spatial analyses. For example, site location could be masked by taking a site's actual location, choosing a random direction, and then choosing a random distance. That might be enough to ensure that unauthorized personnel could not find the actual site, but not so far off that it would impede spatial analyses. Such an approach would also alert analysts to the maximum level of error in spatial data and allow them to decide whether it is acceptable for their research. And we conclude by saying that the era of big data is upon us. And I want to say that this statement is a clarion call for why we need collaboration across all stakeholding communities. We can no longer work in our silos. It requires that we rethink how we approach the control and dissemination of information. And that means an open dialogue concerning the quality of open source spatial data. If not, our discipline will miss a unique opportunity to make important contributions to the public that funds our work. And if we cannot learn from prehistory, then that hands ammunition to those who seek to recall protective legislation. The future preservation of the archaeological record goes hand in hand with its ability to be used by researchers and accessed by all stakeholders. So, the final topic, what can an integrative and data-driven framework do for Idaho archaeology? All is not lost. There's a very, very bright light at the end of the tunnel. What I said with the Idaho radiocarbon database being relatively underrepresented compared to other states, that's an exciting opportunity for all of us to integrate all of our ones and zeros into a collective apparatus that has a clear and collectively defined light at the end of our tunnel. Works like this from Michael Hyland, the role of modeling and synthesis in creative mitigation give us hope for this future. In the 54 years since passage of the National Historic Preservation Act, more than 56 million hectares of land have been surveyed in the United States, and nearly 1 million cultural resources have been identified and recorded. These efforts have produced hundreds of thousands of project reports, vast collections of data, and a wealth of descriptive information about the past. The accumulated data can be used to generate important new knowledge about the past with many scientific, management implications, but remain largely untapped. Following current approaches, many resources will be damaged or lost if before effective strategies for studying or preserving them can be developed. Synthesis and modeling are needed in creative mitigation efforts to identify which resources to preserve and study and how best to do so with limited time and funding. This article explores the potential for compiling and synthesizing large cultural and environmental databases within a GIS to model the nature and distribution of cultural resources. It is argued that dedicated synthesis and modeling of cultural resource management data will allow development of more effective and proactive research and management strategies, providing lasting benefit to diverse scientific and traditional communities and the public. And boy, has the stage been set for Idaho. So in the land exchange of BLM and the state of Idaho in the Owyhee County, Kirk Halford and colleagues created on a very exciting predictive model for site sensitivities. And they create areas with overlays where they look at the most sensitive sites, and they're able to predict where potential sites will occur on the landscape using the wealth of data that's been developed and accumulated by past cultural resource management work. And they state specifically, as a result of the various phases of testing and field application, we believe the model provides a viable tool for informed decision-making and in assessing the effects of the proposed undertaking on resources. Modeling allows for pragmatic, creative, and research-oriented solutions for addressing 106 compliance, taking into account what we understand about the archaeological record and past human behavior after nearly 100 years of archaeological investigation in the region. So this brings up a very important point that I want to try to make to you all today. Throughout the development of CRM and academic-based archaeology, academic archaeologists have been able to focus on their niche interests, certain interests. There has been a legacy of good interactions here in the West of cultural resource management bridging this academic and CRM gap. With Halford and colleagues and Hyland and colleagues, and with this move towards big data, especially as we consider how the role of Section 110 work is going to increase, I think that this helps us address a key question, and that is, what are the roles of universities in this new integrative framework? And Halford and colleagues identify it as such. We determined that our current effort could be refined to provide more robust predictive power by modeling the 3 separate environmental zones independently to capture the unique variables and qualities of each habitat. Refining and improving upon stream, spring, playa data would further increase model predictive effectiveness in all environmental zones. Application of standard deviation of slope using a finer grain DEM would help define low-lying rock outcrops where shelters may occur, as well as steep cliff faces along river corridors. What has been identified is a space, a gap, or a space that archaeologists can uniquely fill. It identifies specific problem-oriented training opportunities for our students to work with these models that have been produced by the federal agencies to further refine them, because we should be training within the context of us refining these models. That is the contribution that we in universities can make, not only to train the next generation of resource managers, but also to provide a product in our university that is fulfilling our public service mission in contributing back to these agencies. And they close with another potential answer about the place of universities in all of this. Finally, we would be remiss if we did not call some attention to the precedent set and continued by this project. BLM Other federal agencies and tribes manage tens of millions of acres in the Western US. Executive orders notwithstanding, those lands will never be fully inventoried. Model-based approaches to actual undertakings will become more common over time as confidence in the use of models increases and models improve in predictive power. This project has benefited from model-based approaches used elsewhere in southern Idaho, and we, as cultural resource professionals, are interested to see how federal and state agencies, as well as tribal governments, can make use of these approaches to inform decision-making. Our suspicion and hope is that the profession as a whole will blend model-based planning and survey strategies with effective fieldwork, yielding real knowledge of our past. As someone who is responsible for running a summer field school that trains the next generation of archaeologists in Idaho, my work and my training in the summer can be specifically focused on ground truthing these models. My students learn how to survey these sites, and we can get stuff done with these large crews. So we're training and we're helping the federal agencies at the same time. Closes by looking at the modeling, the relationships between modeling Section 106 and the integration of all stakeholder communities. Modeling represents a tool for Section 106 compliance that represents a cost-effective method for analyzing large project areas, and we would argue represents a reasonable and good faith effort in the analysis of effects of a project on prehistoric properties and cultural resources in general. Most importantly, they allow research-based approaches to considering human behavior on a landscape level, benefiting from over 100 years of archaeological inquiry and deeply embedded Native American knowledge. In sum, a more meaningful and thoughtful investigation of human land use patterns can be realized. So there's one outstanding aspect here, and talking about the involvement of Native American knowledge, okay? One of the largest movements happening right now in open science, open access-based approaches is this principle called FAIR. It's found on the right here in this figure. And FAIR stands for data. To build big data in archaeology or in science in general, we need to satisfy these four principles: findable, accessible, interoperable, and reusable. And the open data charter principles held are that things need to be timely and comprehensive, they have to be accessible and usable, and the databases have to speak to each other. Databases are not effective for integrative work if their metadata is not similar and they cannot talk to each other and be interoperable. However, this leaves outstanding an entire issue about the involvement of indigenous communities in this. And there has been a group of folks around the world to develop what are called the CARE principles that complement the FAIR principles. And this is the CARE principles for indigenous data governance. And they are, the C stands for collective benefit, authority to control, responsibility, and ethics. And the open data charter principles of the CARE Act are for improved governance and citizen engagement, for inclusive development and innovation, and things are open by default. They close with a statement that is another, it puts out another standard for action and how we want to develop these databases and these interactive data-driven frameworks. And they say that CARE principles draw from, integrate, and build on the work of mainstream stakeholders focused on data reuse, as well as the efforts of indigenous-led networks and coalitions focused on indigenous data governance and research control. While centering data in the FAIR principles complements other efforts to inform responsibilities for data principles, producers, and repositories, the CARE principles extend that work to actions that align with the people and purpose for which data exist and are used. As the mainstream community of data shareholders advances standards and practices to facilitate data reuse and research reproducibility, the CARE principles enhance that work by reversing historical power imbalances. The CARE principles address historic inequities by creating value from Indigenous data in ways that are grounded in Indigenous worldviews and by realizing opportunities for Indigenous people within knowledge economy. The implementation of the CARE principles in tandem with the FAIR principles will result in data that reflects the realities of Indigenous peoples, be useful for Indigenous purposes, and remain under Indigenous control, while promoting knowledge, discovery, and innovation. The CARE principles are a guide for data producers, stewards, and publishers to affirm Indigenous rights to self-determination through careful data practices that will ultimately address complex issues related to privacy, future use, and collective interests, and increase the value of data for reuse. Just as the FAIR principles are a precursor to good data management and stewardship practices, the CARE principles encourage data users to be both fair and care. Our work in the Great Basin recently has been focusing upon reconstructing human population ecology over the last 14,000 years. And what we can do is that we can look at this empirical record on the x-axis from 12,000 years ago, 12,000 BC to 2000 to the present. And we can look at this black curve here, and this black curve represents the frequency of radiocarbon dates. We can compare this to all kinds of null models to understand when population growth is significant compared to what we might expect, or less than what we might expect. This enables us to overcome the inherent biases in calibration of the record, sampling biases, all of these kinds of issues. But what I want to talk about is how we kind of break down this Great Basin record. And it really gives us a great sort of framework from which we can start to understand and consider Idaho archaeology across the broader region. So we're assessing the role of interregional variability of environments and human populations over the last 14,000 years in the Great Basin. And what we're doing is that this is the same statement, is that we cannot solely look at human demography irrespective of the ecosystemic context in which that demography was taking place. So we've broken this down into multiple different floristic zones, climate zones across the Great Basin. And we have developed a series of population curves throughout this period of time. You're looking west here, you're looking northwest, you're looking at the lake sector of Southern Oregon, you're looking at the North Sierra in front, the South Sierra in front, the Southern Great Basin and Mojave Desert. On the right, you're looking north to south on the western or more the eastern part of the Great Basin. In the north, you're looking at the Owyhee Desert and Snake River Plains. You're looking at the Lahontan Basin south. You're looking at the Central Mountains Archaic and the Bonneville Basin. And what you need to see here is focus on the top right plot, the Owyhee Desert and Snake River Plains. The red represents population booms, and the blue represent population busts. All these is a comparison to a statistical null model, and it's different than that null model. So we see it as a statistically significant rise or decline in populations. But what's most important is that what we can see is that when we break down the Great Basin into these different floristic zones, we actually see very different patterns of population growth. And if you're looking at the occurrences of numbers of blue and red bars on this plot, what becomes very apparent is that the Owyhee Desert Snake River Plain area has the most stable populations throughout the Holocene, and also it is, experienced some interesting events. So the 8.2 Ka event is a major climate change event, does not seem to be affecting these populations. If anything, they slightly peak afterward. This is in the early Archaic period. What we can clearly also see from this is that the Mazama ashfall undoubtedly had an impact on these populations in this region. And then we get the Middle Archaic here represented by this hump. That's a very interesting time where, we get probable in intensification of resources, things like that. But it is bookended by both of these periods of population declines, right? But populations rebound immediately afterward, right? And they actually, what we see that's so unique in this area is that we don't see a population drop leading up to the historic period. And we oftentimes see that around the country. So we have a powerful record for looking at long histories of human environment interaction and the development of population ecologies here in the West. But we have something more powerful for that and than that. And that's where indigenous oral histories and knowledge really come into play and can actually help us design the way that we work in archaeology right now with these big data sets. And the classic thing is that if we look at the Lahontan Basin record, and we took this radiocarbon records as a sole direct indication of where humans are living, we would read this and say, oh, well, there's people coming in between about 9,000, 8,000 BC. And they're living here. Then there's a small bit in the middle Holocene, and then these groups increase. However, that's not respecting the oral history in a way, because there is a unique oral history in the Lahontan Basin of the Fallon Paiute Shoshone that shows that residential sites, that says that people, this was a sacred landscape, okay, and people were burying the dead, but they were not they were not living in this landscape. And what we've been able to do using these radiocarbon records is we've been able to break down the site types. So look at more of the context of these radiocarbon dates. Try to imbue more information in them. And looking at Western mortuary caves, mortuary cache caves on the western part of the Lahontan Basin, looking at Eastern mortuary cache caves, and then solely looking at residential sites. What we find is pretty remarkable, and it actually confirms and it corroborates that oral history, showing that residential sites were not on that landscape, that it was in fact mortuary sites. So if we archaeologists did not listen to our indigenous colleagues, right, and the oral histories of the land of the people who lived here for thousands of years, then we are potentially producing false narratives in archaeology, and we need to pay more attention to that. Because what we've been able to do, something that we would potentially thought as humans living in this landscape, what we've been able to do now is actually is really put data to that sacred landscape, and that enhances the sovereignty of those groups in that landscape. That's ultimately what our archaeological work should go and help contribute to. A perfect world would be where we can develop time series, a continuous time series of all kinds of archaeological data. We can't just break down radiocarbon dates based on what's a mortuary cave, what's a residential site, to go even further and say, let's reconstruct patterns of intensification on the landscape. And let's also understand when folks were exchange systems through time, okay? So on the right, we're trying to assess how we can use these time series to understand the sharing between peoples in the past. On the x-axis, the below, it's going now from right to left, 12,000 years to present. What you are seeing at the top is radiocarbon date frequencies right here. At the bottom, you are seeing dated metates. This is from the state of Wyoming. So this is Wyoming has a collective database we're able to search in. And so we kind of saw the potential for imbuing more information into these radiocarbon dates. So what we can do is we can take aggregated calibrated dates in relationship to metates in the record to assess increased or decreased frequencies of plant consumption or intensification of plant use in the past. So that's this gray bar, and it looks very interesting where populations are growing, as a lot of ecology theory would predict. we're seeing the intensification of plant use, the broadening of diets. And we can also look at the bottom. We see these histograms of the distances, the maximum transport distances of obsidian. Okay, so we can actually look at the expanding and the dynamics of change of obsidian distribution in these different periods of time. So this again, we're not just trying to use the radiocarbon record, but we're also trying to look at the radiocarbon record in space. We can look at dated metates and we can compare them to the radiocarbon record. We can look at evidence of exchange networks and we can compare them to the radiocarbon record. And what we can also do here in this middle plot is we can look at where people are living on the landscape. When are groups clustered in space? And when are groups becoming increasingly dispersed in space? Okay, so we can start to look at, really look at the deep histories of populations in the West using these large archaeological data sets. So key takeaway messages. I know that I've done the ultimate no-no and I've read from a lot of texts in this presentation. I'm sorry, but those words needed to be read. They needed to be heard from the community. These are people who have thought a lot about this problem. And, you know, for instance, this issue of fair and care integration, that's very, very important. And it really defines the future of how we consider an integrative and data-driven archaeology. And so takeaway messages, the first one being that all stakeholders will have to contend more and more with the current movement towards open data and open science approaches in coming years. Databases can enhance the study of the archaeological record, which contributes to its continued preservation. Each stakeholder has unique perspectives and skills that they can bring to the table, which mean that collaborations help us better weather the data deluge. We can better weather this storm if we all work together and put our minds together about how we deal with this, because it's coming, no matter if we want it to or not. Indigenous oral histories can, and in my opinion, should be integrated into archaeological field and research designs. It's gone on for too long, and we must really have a fully integrative archaeological research design process. And lastly, the role that I can play and I want to play in this, and I hope that I have collaborators from other agencies and stakeholder communities. Universities should be focused on training students to meet current agency skill set requirements. The best way to develop these skills is through collaborations with different agencies. Universities are well poised to provide increasing assistance on matters such as Section 110 issues. We should be collaborating with you all, and these should provide the projects which we can then use to train students. So again, ground truthing predictive models. We would love to help you with that during the summer. Thank you very much for your attention. And I again thank the organizers, Drs. Gorell, Plew, and Chapman. Lastly, I want to acknowledge my privilege of getting to live and work on land that is the traditional territories of the Shoshone-Bannock, Shoshone-Paiute, and Nez Perce peoples. Thank you very much.